In this lesson, we're going to take a deep dive into EC2 instance types, key pairs, and user data. It's nice to think of instance types as the hardware footprint of the machine, the amount of CPU, RAM, disk, and virtual internet card going into the machine. Key pairs are used to control the first-time access to a new EC2 instance, although it's a good practice to keep them in place even after. Security groups are semi-stateful firewalls around the instance used to control the access between instances. And user data allows you to store configuration data and/or scripts inside of the instance. This is useful for bootstrapping or pulling up the machine the first time that it boots. Let's first look at EC2 instance types. Again, this defines the virtual hardware, the CPU, the RAM, the virtual NIC or virtual I/O of the machine, and ephemeral disk, which is local disk that comes with some instances. Currently, there are 18 instance types supported, and these are grouped into families, such as M1, the latest M3, cluster compute, graphics compute, and so on. EBS-backed instances can be stopped and resized to a larger or possibly smaller instance type. The caveat there is that your EBS disk has to fit in the smaller machine. Let's look at some of these families. First, let's look at the family of RAM CPU. If we look over at our key on the right, we see that we have T1s, M1s, M3s, and so forth. These are grouped according to their icon. One thing to note about this graph and the next graph is that both of these axes are log. So this machine up here has 100 gigabytes of RAM versus this machine down here, the T1 Micro, which only has a couple. There's also families by disk and CPU. And here you can see that we have disk on the vertical graph. Again, this is a log graph. And you can see that some of these machines come with very high amounts of disk. In this case, the CC or GCs come with much more disk than the T1s, which don't even appear on the graph because they don't have ephemeral disk. There's good feature info at ec2instances.info. Highly recommend you pull this up in your browser and take a look. This is not managed by Amazon, but it's the best resource out there, and they keep it pretty current. Some things about EC2 instance types that you should be aware of. First, you have to define whether it's Windows or Linux. The Windows is going to be a higher cost due to licensing. These are charged hourly, and this is something that always gets first-time users. Let's take a look at what we mean here. It's charged running forward, which means such as T0 here, I spin up an instance. At the top of the hour, I spun up an instance, I got billed for 1 hour. Let's say that 5 minutes later, I didn't like that instance. I stop it and I start another one. I'm billed for an additional hour. You can kind of see where this is going, but every time I stop and start an instance, I'm billed for another running hour forward. So we can see here in this example, we would have gotten 4 hours of charges inside of a single hour. The best practice here is, if you've got an instance up, try to leave it up for at least an hour, or as close to an hour as you can. You're going to be charged for that full hour anyway. Let's next look at EC2 key pairs. These are public-private key pairs. These only allow access to EC2 instances. These are not your access and secret key pairs that you use to sign your API requests. AWS never sees your private. In fact, when you create a private and public key pair, the private is created inside of your browser inside of JavaScript, so the AWS servers never actually even see your private key. AWS loads the public half of this key into your EC2 instances when it boots them up. And the first access to that machine requires the private key. In the case of Linux, you pass in that private key with the -i parameter to SSH. And in the case of Windows, you use this key to decrypt your administrator password. Let's next look at EC2 security groups. These are semi-stateful firewalls which open specific ports. You specify an individual source, as you see here. These can be a CIDR block, which we'll talk about in a second, or it could be another security group. You can also specify TCP or UDP, and the default security group is zero access, which you probably want to keep that way. Launching your instances into the default security group with zero access is another best practice we recommend. Let's look a bit at CIDR blocks. Here you see that we have an IPv4 address, which is the dotted decimal notation. Every separator here is a dot, and in between the dots, we have what's known as 1 byte or 8 bits. A single IPv4 address consists of 32 bits or 4 bytes. Each byte is 8 bits long, or an octet. You specify CIDR blocks with slashes, and when you specify a slash, what you're talking about is masking off the first 2 octets. such as right here. We have /16, which for this address would specify that this is hard-coded, that is hard-coded. The third parameter can be between 0 and 255, and the last parameter can be between 0 and 255. If we have a /24, we're masking off the first 3 octets, or 24 bits, in which case we can have X, Y, Z, which are hard-coded, and the last 3 can be 0 through 255. If you specify a /32, you're specifying a single IP address, in which case we have X, Y, Z, and A all hard-coded. If we look at some more examples with specific IP addresses, you see here that we have 122.43.0.0/16. This would equate to 122.43.anything.anything. This is what is known as a B block, and this is 64,000 addresses. Next, we have this address, in which the first 3 octets are hard-coded, and the last is a 0/24. In this case, we're specifying that the first 3 octets must be set, and the last can be anything. This allows for 255 addresses. Finally, we have the single address, 122.43.65.8/32. This specifies a single address because you're locking all of the octets. An important address you'll be using frequently is 0000/0. This allows all addresses from everywhere. Remember, we can also specify the source as a security group. Let's take a look at that real quick. Here you can see that we plan on having 2 instances we spin up, one in a web tier and one in an application tier. First, we specified the web tier security group. And notice that we specified using CIDR notation. The source of 0000/0 is everything from everywhere. And here you can see that we've opened up the web ports of 80 and 443, which are HTTP and HTTPS. A machine that's wrapped in this security group will only be allowed access from these 2 ports. Next up, we have the app security group. And here we do something unique. We're specifying another security group. So we're specifying that if port 8080 is accessed on a machine using this security group, from the web tier security group, we're going to allow access. This is locking the machine off to any access besides through the web tier security group, so that when we wrap our web tier with that security group, and we wrap a machine on our app tier with its security group, we're allowing port 8080 access from web to application. Let's talk for a second about user data. User data is information that is copied into the instance. This can be used to make a generic instance become a web or an application instance, as you see here. We're specifying the role of production, the owner marketing, and the tier of web in user data when we launch this instance. We're limited to 16 kilobytes of data, but we're really not, because the scripts can use something called cfninit to run scripts on initial boot. Let's look at that for a second. If we pass this string into user data, we're using what is known as cfninit or cloudinit for AWS. Cloudinit comes from the Canonical folks, who also make the Ubuntu Linux OS. It's a package which allows bootstrapping of cloud servers. Cloudinit is not AWS specific, but cfninit is. cfninit says that if user data starts with a hash bang, as we see here, it's going to execute the whole rest of the code as a user, only on the first boot, and it can install packages, set host names, and do wget of codebase and other scripts. This is how we can get around that 16K limitation. We could just wget a script from S3 and run that as well. Here you see in this user data, we're first updating some packages with yum, so we must be on CentOS. We're setting the host name to web01, we're installing Apache Web Server, and we're starting the Apache Web Server. We could continue doing other additional stuff. You can access user data from inside the instance via this 169.254.169.254 endpoint. If you run a curl of HTTP 169.254.169.254/latest/user data from inside your EC2 instance on the terminal, it's going to show you all the information you have loaded in user data. You can also access metadata information. This is AWS level data about the instance, stuff such as the DNS, the hostname, the networking, disks, and so forth. When you get to the EC2 spinning up the first instance lab, highly recommend you remember this slide and come back and curl these two endpoints. In this chapter, we covered instance types, which are the hardware footprint, EC2 keypairs, which allow first-time access to the new instance, security groups, which are the semi-stateful firewalls around the instances, and user data, which stores configuration data and is useful for bootstrapping the machine.